Now let's take a look at the analysis of matched data using the Cochrane-Mentor-Hensel and the odds ratio Mentor-Hensel. So these are different analysis options depending on the type of study that we have here on the right column. So for any type of design, whether it's a 1-to-1, 1-to-M, or M-to-M matched design, we can calculate both the odds ratio and the p-value using the Cochrane-Mentor-Hensel test. If you're interested also in having stratum-specific information, we can add the rare risk option, but that's optional. So let's take a look at these. Keep in mind the matched sets are strata. So pairs are strata, and any matched set is a stratum. So in order to do a test, this Cochrane-Mentor-Hensel test, we set up the data set so that you have 2 observations per individual, or 2 rows. You add a variable called ID to indicate the pair. This is for a 1-to-1 matched. And then you use the CMH option to analyze the matched data. So the pair becomes your stratification variable. And just to distinguish this, we will say that we are stratifying on the pair. If you have many pairs, let's say you have 100 twins, you want to add the no print option. Otherwise, you're gonna see an individual table for each of the pairs printed out. So in this case, we have the treatment or exposure as your exposure and the placebo, and then you have a particular outcome, yes or no. In this case, we have 10 pairs. That's indicated by the number 1 through 10. And then we simply run the proc-freq. You need to remember to include the ID first before looking at the exposure by outcome association. And then you're going to add the CMH option, and no print option is important, especially if you have many pairs. In this case, it might be okay, but if you had 100 pairs, then definitely you want to use the no print option. So by doing this, you're going to see the Mentor-Hensel odds ratio, and this will be your matched odds ratio. So it's 1.67, and these are the confidence intervals, 0.40 to 6.97. So in a 1-to-1 matched design, a case is paired with a control based on similar characteristics, for example, age, and then the exposure is assessed in this pair. So F would be a pair in which the case is exposed and the control is not exposed, and G is a pair in which the case is not exposed and the control is exposed. And then we can simply calculate the odds ratio as F over G. The concordant pairs will provide no information for our calculations or even for power calculations. So in this example, we're going to ignore the concordant cells. We have a pair design where the left foot got the needle and the right foot got the placebo. So this was for the acupuncture example. There was either a response or not. And take a look at the table, how it's been set up. Now, which ones are the concordant cells? The concordant cells are 10 and 20. So we do not really care about these. For the odds ratio, we will divide 40 divided by 25, and that will be 1.6. In ProcFreak, you will get the same results. Now, just to prove that you're really not going to get any information from the concordant cells, try to change these to 1 and 1 right here, and you will find the same exact result as before.